Bom dia a todos e sejam bem-vindos ao Webinário Agilidade e Segurança em Serviços Financeiros, promovido pela Nova 8 e Whitesource. Meu nome é Wilson Bejar, sou consultor técnico da Nova 8. A Lior Murray e eu estaremos suportando vocês durante a apresentação através da opção do chat e seremos seus moderadores. Antes de começar, eu gostaria de passar algumas informações sobre o evento. O webinar será gravado e todos os participantes receberão um e-mail com os links da gravação e cópia da apresentação, que estarão disponíveis 24 horas depois de encerrada a sessão. O webinar vai ser apresentado em inglês e os slides estarão em português. As perguntas poderão ser efetuadas na seção de perguntas, localizadas no painel de controle. Fiquem à vontade para fazê-las em português, que nós passaremos para o inglês, e estas serão respondidas na seção perguntas e respostas após a apresentação. E é com grande prazer que eu apresento o nosso palestrante de hoje, Jason Hammond, que é diretor de engenharia de soluções da Whitesource. Então vamos iniciar a apresentação. Jason, seja bem-vindo and take it away, please.
Thank you, Wilson. And welcome everyone to the webinar. Thank you for joining us today. In today's session about the opportunities and challenges of using open source in your code, we're going to cover these items from the agenda. We'll first start by talking about, in a little bit more detail, the opportunities and challenges open source software provides to development teams. We'll also talk about how to use automation to increase your confidence in your development processes. We'll review some best practices when incorporating security early in the software delivery lifecycle, why that's important. And we'll talk about how to create a trusted development pipeline with the goal of speeding up development and making it more efficient. Now, development teams at all companies want to adopt standardized DevOps processes in order to meet key business challenges. And the use of open source software plays a really big role in helping to meet those goals. So on this slide, you see a couple of important goals that development teams are trying to achieve. The first one's around innovation. So using open source software helps to foster innovation in your development teams. It enables companies to take advantage of the experiences of a very diverse and broad set of individuals across a number of different industries and a number of different disciplines and incorporate that experience into the open source code that they're developing together as a community. It also enables companies to take advantage of approaches to business requirements that your company may not have thought about on your own, right? Just looking at things from a different perspective provides the opportunity to solve a business problem in a potentially unique way. The second goal is around agility. So when 80% of the code in your application comes from open source libraries, then you only have to write 20% of the code of the entire application. And as a result, release cycles can be sped up and you can respond to business demands more quickly just because there's less code to write and less code to have to manage and check and make sure has high quality, right? The total amount of work you have to do is decreased significantly by having to write less code, and that's enabled by using open source. The third area is around making changes in culture for digital collaboration, digital innovation. So using open source shifts culture because it encourages collaboration and it encourages contribution and it encourages responsibility from the contributors to the open source library and the users of the open source libraries. it requires you to participate in the development and the maintenance of the open source software, right? If you find an issue with an open source library you're using, then you have a mechanism to contribute a solution or at least report a problem back to the community. So when you use open source software, you benefit from the work that the community does, and naturally you want to contribute back to that community. So it helps to shift the cultural mindset. How do we actually build code and thinking about it more globally and not just about the goals of your own specific company or your own specific organization within your company. The fourth goal is around collaboration. So open source software provides a blueprint for collaborative software design. By its nature, open source contributions come from anyone who is benefiting from the use of the open source code. And open source relies on continuous innovation and delivery of updates to the open source libraries in order to maintain quality, maintain security, and to add new features and improve the open source product. So this requires solid communication both within your organization and outside of your organization with other groups and other companies. The final goal is around control. So by contributing to open source projects, your company and the people inside of your company that use open source software can drive the strategy, direction, and innovation of the open source projects that you contribute to. So if your company needs a new feature in an open source library, you can actually build it and then contribute it back to the community. And now that product has been improved. Other people can look at it, maybe suggest improvements to it, potentially identify potential functionality or security issues in that code and provide fixes for those, right? Ultimately, you get the benefit of valuable feedback from the community that contributes to a higher quality version of the open source library, and that improves the quality of your application. And in return, the community gets the benefit of the new feature that you are providing, the functional improvement, the improvements that your company is contributing back to the project. So in a way, using and contributing to open source projects makes it possible for companies to control the destiny of the open source projects and that you are relying on to drive the innovation and agility of your applications. Now, for enterprises, it can be challenging to make these changes, right? To take on the mantle of using and maintaining open source. You need to ensure the resilience of each channel of the organization that is going to be potentially using open source libraries, right? So there's a lot of different groups inside of your company, a lot of complexity inside of your company that in terms of application development, right? There's obviously the application teams, there are security teams, there are compliance teams, and they each have a different stake in the application, the security of the application, the quality of the application, the business requirements that the application addresses. And over time, you know, if companies are taking on, for example, acquisitions or merging with other companies, the complexity grows, right? If you are being merged with another company or your company is acquiring another company, but you're also taking on all of the assets of the digital development, the application development of the company that's being acquired or merged, and you're taking on their processes and their code and the potential challenges and security issues and compliance issues that might come along with that. So there are the traditional processes that are in place can present problems when trying to standardize how you're managing security and quality and compliance. So traditional IT processes, they end up driving a lack of communication and potentially result in finger pointing, right? Who's responsible for what? There's more time spent passing the buck, if you will, or passing the ball around and telling different groups you're responsible for fixing the security issue than time spent actually resolving the issues. Things happen very slowly in traditional IT processes because there are things like quarterly release cycles, right, that don't support agility. They take too long. They're there for a reason, right? We want to control the release, and we want to be able to have appropriate time to do unit testing and security testing and functional testing, but it's very slow. There's a lot of manual testing that occurs in traditional IT cycles, right? And very little automation, and that can slow things down and make things more complex. Legacy ITIL processes, and at the end of the day, you have these siloed organizations that don't communicate well amongst each other, right? And so all of those types of things end up becoming challenges for your organization, and don't make it possible to be resilient and agile and efficient with the development of your applications. So that's what, with the old way of doing things, this is what you ultimately get. So traditional IT processes really introduce speed bumps in adoption of modern DevOps best practices. So it's important to understand the challenges, right? The challenges of growth through acquisition, the traditional IT driving lack of communication. Ultimately, you need to take time to understand your software delivery value chain before you are trying to change it. Right? You have to keep in mind the skill set of the people that are part of the organization, right? And you have to keep in mind that you may have offshore resources that are, you may have to wait for communication with them. There may be language barriers or skill set or process barriers when you're working with offshore groups. And those things can provide roadblocks to speeding up your efficiency as well. So at the end of the day, as you go through the digital transformation process and we want to take on more and more open source code to make it easier to develop code and maintain it and innovate it, you will hit lots of speed bumps. And there will be people that are pushing back and saying, well, this isn't going to work in our industry, right? We're overly regulated. So we're going to we're going to need to do all of these compliance processes, right? And we're going to have to do them manually because that's the only way we know how to do them. And they're going to push back on the desire to move fast, right? Alternatively, lines of business may want to move things so fast that they push aside the still important processes of checking for security and compliance issues, right? So you need to have a balance, right? You need to find ways to support the business's need to move faster while also supporting security and compliance and development teams' desire to have security, have compliance, have quality product, right? And that can be done through automation. Now, you don't need a large team to start making a difference, right? You can focus on specific parts of your application that can be improved through automation, right? This is the really automation and finding good tools and processes to support automation ends up being a way to avoid speed bumps or to at least reduce the negative impact of these speed bumps. Things like using containerized deployment can be a part of that, right? And automating the deployment of your infrastructure. Providing ways to automatically test, right? And in the case of open source, and what we're talking about today, where it's automated testing of open source libraries to identify known vulnerabilities and licenses associated with those open source libraries so that we can match those against compliance policies our company needs to enforce. And of course, continuous delivery, right? CI/CD processes. So ultimately, DevOps organizations are looking for ways to revamp legacy tools, their legacy skills, and their legacy processes in support of digital transformation efforts in order to meet the ever-changing, ever-growing, and ever increasing in velocity requirements of the business. So adopting open source software ends up becoming a big part of that process, but it does introduce its own set of security and compliance challenges. So let's dig into that a little bit and talk about the use of open source in code. So open source does play a key role when it comes to meeting the demands of business, especially in the large enterprises and global companies. It also provides cost and innovation advantages because the use of open source enables development teams to utilize many developers, right? Even developers that you don't pay for, they're not on your payroll, they don't work for your company, contributing to the code. So everybody contributing to the open source project you use in your code is in effect contributing to the code of your application, right? And the fact of the matter is you simply can't develop software at the pace that's required today without using open source software. Right? It's really become a necessity. So some of the largest businesses in the world have an open source first strategy for developing applications. You know, they come at their applications thinking about using open source that already exists, but also writing new open source and contributing it in order to improve the community and make things better and more, and make things work together better. So companies like IBM, SAP, General Electric, Comcast, Optum Health, and scores of others, they're using open source whenever they can, right? They're always keeping open source at the front of their minds as they're building their applications. So, and they do this because open source helps their companies to build better products and to build them faster. After all, really, why would you want to reinvent the wheel when the wheel can easily be downloaded from GitHub, right? It doesn't make any sense to start over from scratch. The tool that you need is already available and freely downloaded with little cost to your organization, right? And no direct cost. You don't have to pay for open source. So as a result, the use of open source software used by companies is growing. And from our estimations, Whitesource Software's estimations, anywhere from 60 to 80% of an average application's code base ends up being comprised of open source code. Now, companies must address business requirements that run the gamut from exposing data of a multitude of systems sourced from acquired businesses to providing cutting edge embedded technology like banking on internet connected devices and mobile devices, right? It's an example of that. And as you can see, using open source software in support of innovation and agility goals, ultimately that makes a lot of sense because it reduces the footprint of custom code that you have to deal with. But the data exposed by these dynamic and innovative open source applications and open source products that you use in your applications, right? It's still very sensitive, right? The overarching application as a whole is still dealing with sensitive data and may be subject to either regulatory compliance or also compliance requirements enforced by open source licenses associated with the open source libraries you choose to use. So look, any company can't afford to expose themselves to the risk of a cyber attack, for example, that results in exposure of sensitive company data or sensitive customer data or financial data. They can't afford to have a breach like that get their company's name in the headlines or even worse, in the courtroom. So you can see that open source has a lot of benefit in terms of making it easier to be innovative and agile, but the use of open source comes with responsibilities. The fact that your team didn't actually write the open source code you're using, right? Doesn't mean that it's not your responsibility to ensure that the components in your application are secure and comply with your company's policies, right? So in order to be able to meet your responsibility as it comes to the security and compliance of your application, you need to establish a reliable inventory of every open source library used in your application, right? Whether that's a direct call to an open source library or a indirect call to an open source library that is a transitive dependency of one of the open source libraries you choose to use. Right? You need to have a visibility to every single library. You need to identify the known vulnerabilities of all of those libraries, and you need to make sure the open source libraries you are using are in compliance with your company's policies. So those are three important things that you need to accomplish if you're going to be using open source. Now, let's talk about open source license risk for a second. Open source software licenses can very well expose your company to risk if you're not careful about how you manage them, and if you're not careful about ensuring you understand the licenses and your responsibilities as laid out in the language of the licenses. Open source licenses have varying degrees of permissiveness and restrictiveness. If your applications use open source libraries with license that require, for example, they require your company to pay royalties if you use that open source library, or they require your company to comply with copyright protections related to the entire application, or a license that requires you to publish your own code as an open source project if you use that open source library. That's sometimes referred to as copyleft restrictions, right? You need to be aware of that. So some open source licenses ultimately may impair your company's intellectual property rights and make it hard for you to be able to achieve the business goals you're looking for. If you're trying to build a commercial application and you use an open source library with a license with a copyleft clause, you have ultimately just given up your rights to actually monetize that application. The copyleft clause requires you to publish your application as a free open source project. So those are important things to consider. And what the slide is showing you is examples of lawsuits that were filed by the owners or maintainers of open source libraries against companies that used their open source libraries but didn't comply with the open source licenses that were associated with those libraries. Another thing that you need to keep in mind is that you need to make sure that the libraries you're using are in fact open source, right? And that the libraries, the open source libraries that you use, have open source licenses associated with them, that they're not masquerading as open source and really end up being commercial libraries with commercial licensing associated with them. So validating that the libraries you use are in fact open source is an important task. And ultimately, if you are not in compliance with the clauses and responsibilities outlined in the open source licenses that are part of the open source libraries in your project, you can inadvertently expose your company to legal or financial challenges. So let's talk a little bit about different types of vulnerabilities that open source libraries commonly are exposed to. The slide you see here is a slide that Whitesource put together based on our analysis, and it outlines the most common vulnerabilities that we see in open source libraries. And you can see the largest percentage of open source vulnerabilities revolve around cross-site scripting vulnerabilities, followed by input validation vulnerabilities and buffer management errors. So let's talk a little bit about those, the largest or the highest probability vulnerabilities that you might run into. when using open source libraries. So firstly, cross-site scripting vulnerabilities, right? Those can expose your application to a session hijacking attack, or potentially disclosure of sensitive data, or potentially forged sessions, right? A attacker could impersonate another user of your application using a cross-site scripting vulnerability. Information leak and disclosure vulnerabilities. They cause applications to reveal sensitive data about the technical details of the infrastructure they run on, like the web application server or the virtual or physical servers that they run on, or even user-specific data like the information about administrators of the environment. And sensitive data being disclosed in that way can be used by an attacker to exploit the target web application, its hosting network, or its users, right? If I can get information about the specific type of web server and the version of the web server your application is using, and I can become aware of known vulnerabilities that allow me to do a buffer overflow attack against that web server so that I can get escalated privilege and then navigate the file system behind that web server, that's really bad, right? The third type of common vulnerability is around input validation vulnerabilities. And input validation vulnerabilities expose an application to an attacker that submitting code to execute a command in an application via an input field, for example, in a web form, right, or a field inside of a mobile application. And those types of vulnerabilities can result in an attacker being able to read or delete data from a table behind the application. For example, if you are subject to an input validation vulnerability and an attacker submits a SQL statement, drop all from star, inside of a form in your mobile application, then they may be able to cause your database to dump all the data, right? Obviously causing your application to start failing. So those are common vulnerability types that we see out in the world today. And ultimately, what I'm trying to show you is examples of how you can see that it's important to verify that each and every open source component you use is secure. And from a license risk perspective, it's important for you to understand the licensing of each and every open source library you use and make sure that your company's compliance policies are in line with the legal clauses in those licenses. And that problem becomes more and more complex. It's very difficult to do this manually, especially at scale. And if your company is increasing its use of open source over time or merging with other companies, then that problem gets exacerbated. So this is because the information about, well, it's difficult to manage this because information about open source components is scattered across hundreds of sources of data on the internet, each one with a different level of credibility. And most of the databases that this data resides in aren't easily searchable. And they're certainly not easily searchable manually at scale. In addition, it can take a tremendous amount of manpower to actually do the research required to analyze the vulnerability and license information of all of the open source libraries you use across all of your applications and compare that to all these dozens and hundreds of repositories of data across the internet. And the problem is only getting worse and more chaotic. So why is that? Well, in recent years, we've seen a spike in the total number of reported open source vulnerabilities as awareness of vulnerabilities rises, and also as the use of open source libraries rises. While more developers are using open source code, there's obviously more eyes on the open source code, and those more eyes are able to detect more vulnerabilities. There's also the fact that as open source projects mature, the average number of transitive dependencies across open source projects also rises, right? I just talked earlier about why it makes sense for you to go download an open source library from GitHub and use that in your project instead of writing your own code. Well, guess what? Developers and maintainers of open source libraries do the same thing, right? If they want to introduce a new function into their open source library and they can find another open source library that provides it, they're going to go get it instead of writing it themselves. And that secondary open source library becomes a transitive dependency of the open source library that other applications end up using. And the time it takes for bad actors to start attempting to exploit known vulnerabilities is shrinking as well. And that's what the graph on the right side of the slide is showing you. Ultimately, what that means is that once a vulnerability is known and is published, then attackers are able to very quickly turn around and start trying to exploit that vulnerability. So the time that you have from the point that the vulnerability is published to the time that you need to patch it in order to avoid becoming a victim of an exploit, that time is shrinking. So now we've talked about the challenges and risks of using open source, but let's talk a little bit about the opportunity that is provided to you when using open source. In particular, if you're using open source and managing your libraries via an online code repo like GitLab. So how can you get the control you need over your use of open source code? Well, I talked about this a little bit earlier, but you really need to establish a reliable and comprehensive inventory of all of the open source libraries you use in your applications. Right? You need to be confident that you are aware of every single library that's in your application, whether it's a direct dependency or a transitive dependency. And you need to be able to identify all of the open source licenses associated with those libraries, and you need to identify all the known security vulnerabilities associated with those libraries. Ultimately, you need that type of information if you're going to be able to effectively manage and control open source software use in your applications. So companies historically have used three common ways to deal with the challenge of how do I manage open source software. We've seen companies try to manage this manually through spreadsheets or through email or through communication tools like Slack. But if you're doing it that way, then you're asking your development teams to track the usage of open source code in all these manual ways, and it's not scalable and it's inaccurate, right? It provides the opportunity for human error. So putting that load on your developers and requiring it to be manual only slows down your developers, right? It makes them spend precious time documenting the use of open source code instead of building applications. The second thing that you could do is nothing, right? And we see companies that go into denial. They turn a blind eye to it. This is not my problem, right? But obviously doing that is really risky because it exposes you to all sorts of security and compliance risk. But the last thing that you can do, and the thing that Whitesource and Nova 8 suggest you do, is to automate your processes, all the processes related to identifying open source libraries and identifying the licensing and security vulnerabilities associated with all the open source libraries. That provides your developers with the opportunity to rely on the automation and just focus their efforts on building cool applications and important applications. So we're suggesting automation, but we want to give you a little bit of a view into what's life like before open source software management is automated. We've reviewed scanning that our company Whitesource has done of projects with our customers, and we found some metrics that we presented to our customers that they found to be very interesting, and so did we. So when we scan a code base and are able to build a comprehensive bill of materials of all of the open source libraries across all the applications that we scan, and then we give that list to our customers, many of the evaluators that we speak with tell us that they're only aware of 50% of the open source libraries that are actually in use in their applications. And the other 50% they weren't aware of, right? So more than 75% of the people that we spoke with told us they only identified or are familiar with 50% of the libraries we told them that they were using. And the biggest blind spot that they were seeing was around the transitive dependencies in their code. Those are much harder to track, especially if you're using manual processes. So if you're not familiar, right, computer programs have direct dependencies that are functionality that's exported by a library that's explicitly referenced in your code base, right? A transitive or indirect dependency is any dependency that becomes induced in your code by the components that the code references directly. Okay, so when we're talking about direct and indirect or transitive dependencies, that's what we're talking about. Now, the second thing that we uncovered and presented to our evaluators, and they provided us feedback on, was that almost 90% of applications that we scanned were vulnerable to at least one known security vulnerability, but 45% of the libraries that we were aware of in our scans had 5 or more vulnerabilities, right? So that became a pretty big challenge, right? A pretty big thing for people to be aware of. The people we talked to at our customers reported that they were constantly in discussions or arguments between different stakeholders involved in the application development lifecycle. So research and development teams and security teams and application development teams constantly arguing about who is responsible for resolving this compliance issue or this security issue. As an example, when a security analyst gets a report of vulnerabilities for an application, they take that list to the developer. They just say, here are the vulnerabilities in the open source libraries in your code. It can be really difficult for the analyst to also provide the developer with evidence of the vulnerability to the developer and tell them where in the code that that vulnerability or that security issue is present. It becomes difficult to tell them, for example, which line of code that is invoking that library with that vulnerability. And that creates a lot of testing and research that a developer has to do to A, try and determine if that library actually is in use in their code, and B, is the vulnerability something that their application is really susceptible to, right? And so that creates a lot of overhead on developers. Evaluators also reported that on average, the open source libraries were in use in their products that had at least one open source license that was out of compliance with their company's policies. But we also found that that one license that was out of compliance was associated with more than one library, or that that library was in a lot of different products. So a lot of applications ended up being out of compliance with corporate policies. So when you see that this is what life is like before open source software management is automated, then clearly if we can make this better by automating those processes, that can have a really big impact on the security and compliance posture of your applications and of your company. Now, Whitesource, we chose collectively and collaboratively to work with GitLab in order to add additional capabilities to GitLab's online repository. The online code repository. Now, GitLab has a lot of great security features that help to manage code, right, and improve the security and compliance of code comprehensively. Whitesource is adding to GitLab the ability to do a really great job as it's related to open source code. And as we spoke about previously, open source code being somewhere from 60 to 80% of an average application's code base, effectively managing open source can have the biggest impact on the security and compliance of the applications. So Whitesource integrated our market-leading open source management solution with GitLab's out-of-the-box security features in order to provide a comprehensive solution to manage the security and compliance of open source code that's managed instead of GitLab projects. The Whitesource integration adds automated management of open source to GitLab security set. So here are just a couple of screenshots and examples of some of the things that Whitesource brings into the GitLab security environment. So the first thing is we're able to do security vulnerability checks of repos inline. And what you see at the top of the screen, these 2 commits, right? So the first commit, when the commit was made, Whitesource integration with GitLab was able to scan that commit to see if there were any vulnerable libraries inside of that commit. The green checkbox tells you that that commit was completed and no security vulnerabilities were identified. But the second commit, we can see that some security vulnerability was identified in that commit. And by drilling into the results of that commit, just by selecting the commit, you can get a list like you see in the lower left-hand corner of the screen to show you the vulnerabilities that were identified in that commit. And it shows you their severity, their CVSS score, shows you the CVE that describes the vulnerability in question. And in addition, inside of GitLab, we can create issues so that a developer can actually see an issue with their code related to the security vulnerabilities that Whitesource identified. And so we drill down a little bit more into these issues, right? For any single one of those issues that was created by our scan that was triggered by the commit, we can drill in and see which library is vulnerable to the security vulnerability, what's its severity, and even, and maybe more importantly, a suggested fix, right? We're not just telling you that the vulnerability is present, we're also giving you a suggestion on how to resolve the vulnerability, right? The suggestion could be things like upgrade to a specific version that is known to be patched and no longer have the vulnerability. Or it could be a suggestion to not use that library at all and use an alternative library for the function. So that's one thing we do. And the other thing that we're showing on the right side of the screen is information about the vulnerabilities inside of the issues list for the application. Right, and so this is, you can see the list of the vulnerabilities. So I just go back quickly one slide. You have these issue numbers that are associated with specific vulnerabilities identified as part of a commit. And each one of those issues shows in the issue screen for the application. And this is what it looks like, what you see on the right side of the screen. Because they're opened as issues, then you can see which vulnerabilities remain unresolved and which ones have been closed. Okay. Now, because we're able to generate these issues, what we can do here is, we identify the issues and we can identify potential fixes to them. So another important part of the Whitesource integration with GitLab is the ability to automatically create merge requests to resolve the issue. Okay. So what you see here is a merge request that was automatically created by Whitesource inside of GitLab that is updating a specific library. In this case, it's this library called Lodash, and updating it from version 4.17.2 to 4.17.12. We're doing this because we know that version 4.17.12 resolves the security vulnerability that's associated with the issue that we resolved. Okay, and so the merge request also shows you which specific issues would be resolved by merging this merge request with your project. That's what you see under the GitLab issue column. And the severity of the vulnerabilities in question that would be resolved. So all the developer has to do is look at the merge request, understand what it's doing, and then choose to accept it and merge it into their project. And the security vulnerabilities are patched and the issues are resolved. So this type of automation saves developers a ton of time in terms of research, manually creating merge requests, and all this sorts of things, right? We can automate this process and speed up their ability to remediate security vulnerabilities in the open source libraries they use very quickly. As you can see, through our integration with GitLab, we enable the remediation process for vulnerable open source libraries inside of GitLab repositories. Whitesource can detect vulnerabilities in open source libraries. We can automatically open issues for each vulnerability. We can identify potential fixes to remediate the vulnerability, and then we can automatically generate merge requests to make it easier for the developer to remediate the vulnerable libraries in their applications. Now, if you're a user of GitLab Ultimate comes with a whole nother set of tools that GitLab provides. And one of those key tools from a security perspective is a security dashboard and a pipeline report. So Whitesource for GitLab provides details about security vulnerabilities that we have identified in the open source libraries in a GitLab repo, and we can expose that information directly in the security dashboard. So this makes things easier for the developer by enabling them to see open source vulnerability information directly in GitLab, the tool that they're already using to manage their code repos. And it supports their efforts of the company to increase agility, efficiency, and speed of the developers. So ultimately what we're saying is there's a lot of different security vulnerability information that can be gleaned and exposed inside of a security dashboard in GitLab. Right alongside with the static and dynamic code testing that bubbles up potential issues in the custom code that's part of the online repos. Whitesource can be integrated with that in order to highlight and present right alongside the results from SAST and DAST scanning, the results of our scanning of open source libraries, right? So the developer can see it all in one place. And again, that's an even bigger improvement over what I showed you in the previous 3 slides. We can also show directly in build pipelines a report showing vulnerabilities that were identified. So when integrated in this way using GitLab Ultimate, when you run a pipeline build inside of GitLab Ultimate, then part of the pipeline can be a task to execute a Whitesource scan. And at the end of that, we will generate a report that will make you aware of which vulnerabilities we detected in the open source libraries that were part of that build. So this is really important because, again, transitive dependencies come into play. And those transitive dependencies maybe don't become visible to a owner of a GitLab repo until they actually execute a build pipeline that uses a package manager to pull the transitive dependencies from their online repositories. So by doing a scan at the end of the build process, then you're getting a comprehensive view into the potential vulnerabilities or the actual vulnerabilities of open source libraries in the build. And you can see here, there's a link here to view full report. So in addition to that, we can actually generate the report and we can do that as part of a build pipeline, but we can also do it when you're just doing a standard merge request. So if a developer is building a merge request to bring in a library into their online repo, then we can bubble this information up before the merge is committed. So at the end of the day, right, throughout the software development lifecycle, it's important to use your development security analysis resources efficiently. What that means is allowing your developers to be efficient in how they do things and not spend a whole lot of time with remediation and research. We want them to be focused on building code. If you imagine a scenario where you're able to use a tool like Whitesource to become aware of all the security vulnerabilities that are associated with your open source libraries, and we're able to trigger alerts to developers about those vulnerabilities, well, those development teams may drown in those alerts, right? They can't possibly keep up and respond to all of them and remain efficient. So you want prioritization of remediation efforts becomes really important. What you want the developers to be doing is to remediate only at least prioritize their efforts to remediate the vulnerabilities that are actually exposed in their code, right? So that can be done, and it can be done in an automated way. You can use open source scanning tools like Whitesource to create a call graph of the code that provides traces from the custom code that a developer wrote to vulnerable functions inside of open source libraries, right? So by doing this, we can determine if the vulnerability in an open source library is an effective vulnerability, which means that we're able to establish a trace from your custom code to the function inside of the open source library that is associated with a known vulnerability, or if it's ineffective, right? The open source library is there and has the vulnerability, but your custom code doesn't call the vulnerable function, and therefore you're not actually at risk of being exposed to that specific vulnerability. And when we can do that, then we can provide that information to developers, and then they can prioritize their remediation efforts to fix the effective vulnerabilities, and then deprioritize their efforts around remediating and fixing the ineffective vulnerabilities. Now, Whitesource's research shows that in an average Java application, 85% of the vulnerabilities associated with open source libraries in the Java application are ineffective. So if you can do this type of real-time awareness of effective and ineffective vulnerabilities and provide evidence to support that identification, then you can save your developers you can make sure that your developers are fixing the actual vulnerabilities that are exposed. That ends up being, again, 15% of the total set of vulnerabilities, right? So significantly reduces the total amount of effort needed to remediate the application and make sure it is secure. And it also makes sure that your developers aren't inadvertently wasting time remediating vulnerabilities that really aren't susceptible or exposed inside of the application. Now, it's important to keep in mind that open source libraries aren't only used in source code, right? Open source libraries also reside inside of containers and container images. They also reside inside of serverless computing environments like AWS Lambda functions. So the tools that you use and the processes that you use to identify open source libraries and their vulnerabilities and licenses, they also need to be applied to container registries and Docker servers and Kubernetes environments, so that you can make sure that, and serverless computing environments as well, to make sure that you are not inadvertently introducing vulnerable open source libraries through those mechanisms. So I bring that up because ultimately, and in summary, we want you to be thinking about 3 key areas when you're thinking about how do I automate open source software management, and when you're thinking about the tools you use to accomplish that. The first one is about completeness, right? Your open source management approach should offer a one-stop shop to manage all of your open source libraries, regardless of which environment or which language you're using. And it should also service the needs of all of the different constituents and stakeholders in your company who have a stake in your applications. It should support security teams and it should support development teams, but it should also support your DevOps teams, your legal teams, your compliance teams, and even upper management. You need to be thinking about prioritization. You want to make sure that whatever approach and tooling you use doesn't trigger false positives and doesn't waste time by having research and remediation efforts being done by developers that aren't fruitful, that don't actually provide a tangible improvement in the application security and compliance. And finally, remediation. Right, the open source management approach should not only let you know that issues exist and vulnerabilities exist or compliance issues exist, but it should also help you to remediate automatically those issues that are identified, right? Generate merge requests automatically, suggest fixes, initiate automated workflows in order to help streamline and automate the remediation process so that your environment can be more secure and more compliant with relatively little effort by your teams. So with that, I'd like to open the floor to questions.
Thank you very much, Jason. We had a few questions that came in. So first question from our audience is, could you give a tip what to say to developers that are reluctant to move from DevOps model to the DevSecOps model?
Oh yeah, yeah. You can tell them about how if they adopt effective DevSecOps processes, then they're going to be saving them a lot of time, right? Talk to them about as being the developer, they have the opportunity to have a real tangible impact on the improvement of the security of their application, right? And keeping your company out of the courts and out of financial litigation issues, or or out of the headlines. And having ways to use tooling to simplify and automate the process that the developer can use to be a part of that solution, and integrating that into DevSecOps processes will make it possible for them to do that with really very little change in what they do day to day, right? I guess at the end of the day, what I'm saying is use tooling and consistent processes as a mechanism to encourage the developers to be part of the solution of adopting DevSecOps, right? Don't make them feel like they have to do it all on their own, or that it has to be done manually. Help them understand that you're going to provide them with consistent tooling and processes to support their efforts to do that as efficiently as possible and without putting undue workload on them.
Great, thank you so much, Jason. The next question that came here is, how does Whitesource manage vulnerabilities? Is there a central repo for that it fetches vulnerabilities from?
Yeah, I kind of alluded to it during the presentation. Whitesource has a team of security analysts that capture information from dozens and hundreds of online repositories of open source libraries and their security and license information. So obviously we use the National Vulnerability Database that is supported and maintained by the National Institutes of Science and Technology, but that's not the only source we use. We use lots of other online repositories that have vulnerability and license data as well. Our team curates that information and brings it into our database. Our security analysts also do their own testing, and so sometimes we will, as a company, become aware of a known vulnerability before it is ratified and published in the NVD, and those vulnerabilities are part of our database as well.
Great, thank you, Jason. The next question here, does Whitesource solution provide a code scan tool?
Yeah, we do not. We focus on looking through code and identifying the open source libraries in that code. We don't scan code and look for potential lines of code that could potentially be security vulnerabilities. There's some important pieces of that. The fact that we don't scan code in that traditional way means that our scans operate much faster. They complete much faster. They don't take hours to complete. And you have a lot fewer false positives, right? Because we're not just looking for things that are suspicious. We're identifying open source libraries that are known, right? That are ratifiable. They're absolutely there. There's no question about it. And so we're not just guessing. And so the things that you are working on are really vulnerabilities and licenses really associated with actual open source libraries.
Thank you so much, Jason. Another question here. What languages are supported by Whitesource and the GitLab integration?
Oh, that's a good question. Well, Whitesource supports 200 different languages, and we can provide in our follow-up a link to the part of our website that shows you the list of languages that we support. And because of the fact that we use our standard scanning agent, which we call the Whitesource Unified Agent, in our GitLab integration, if we're scanning repos or we're scanning commits, we're using that same technology, and therefore the same 200 languages are supported. So it's a really great question, because most of the other tools that are out there on the market support a very narrow set of languages, usually somewhere in the neighborhood of 5 to 10 languages. But I talked a little bit about legacy processes. Well, legacy processes were there because you had parts of your company or the company that you acquired that were building applications before you were focused on Java and JavaScript and Python and so on. So you want to be able to, the security vulnerability still may exist in open source libraries used in a COBOL application, for example, right? So our tool having that extensive set of language support can potentially become important for a company that has a very heterogeneous code base.
Great, thank you so much, Jason. It looks like that was the last question that came in. Thank you so much for the great presentation and for answering all the questions. I just want to remind our audience, you will be receiving the recording as well as the presentation slides after this webinar. The presentation and the questions that were asked today with the answer will be provided in Portuguese as well. So I want to thank everyone again for joining us today and spending your time with us. We know your time is very valuable and we're very appreciative, and we hope that you all have a great rest of the day. Thank you again.